Now let's discuss how deletions are performed. To delete an element, again we have to check for three conditions, including underflow condition. There are four. These are the example scenarios I have made here. The visual representation of example scenarios, Q number 1, 2, 3 and 4 has been given. Let's start writing the pseudocode. While writing the pseudocode, let me discuss each and every scenario. First, you need to check for underflow condition. When it comes to deletion, only if there is an element you will be able to perform deletion. When there are no elements in the queue, if the queue is empty, no more deletions can be performed. So you have to check for underflow condition. The underflow condition is when front is equals to null, when front and rear equals to null, or when if front is equals to null, the rear is also obviously going to be null in a circular queue. So check for the condition. If front equals to -1, print underflow, which means the queue is completely empty, deletions cannot be performed. If not underflow condition, if you check for queue example 1, queue number 1, yes, the queue is completely empty, front is equals to -1 as well as rear is also equal to -1, so it is empty, the queue is empty, which means no more deletions can be performed here in this queue, so it should print underflow. The second condition is, which means if the queue is not underflow, definitely there are elements in the queue, right? Definitely there are elements in the queue. Definitely the first element would be pointed by the front pointer, front variable, and the last element would be pointed by the rear variable. When there are elements, definitely there are some rear and there are some front. Since it is deletion, only at the front end will be performing the deletion. So always you need to focus on only the front pointer, the element which was pointed by the front variable or front pointer, right? So since it is not underflow, I am sure that there are values in the queue. So I am going to create one temporary variable value. Under the value, I am going to fetch the data element which is at the front, and I am storing it under the temporary variable. Now we fetch the value. Now what are you going to do? Whether you are going to increment the front or you are going to change the position of the front to 0, because there are several scenarios here when it comes to the circular queue, right? So once the value is fetched, where we are supposed to keep the front pointer, next we have to check. It depends on the scenarios. It depends on what kind of scenario currently the queue is facing, right? Fetch the value. Now next you check. The very first scenario is if there is only one element in the queue, after deleting that element from the front end, from the front pointer, the queue would become completely empty, right? To check for the condition whether this is the only element in the queue, after deleting it the queue is going to be empty, we have to check. To check that, the condition is going to be if front is equals to rear. Check queue example 2. Here there is only one element is there at the both front and rear is pointing the same data element, which means there is only one data element in the queue. After deleting it, you cannot increment the front or you cannot change the position of the front to 0 here. Why? Because since both the pointers are pointing the same value, after deleting it the queue would become completely empty. So if the front is equals to rear, if this is the scenario, we are supposed to set our front as well as rear equals to -1. This is one scenario. Else, if this is not the scenario, check example 3, Q number 3. The condition is the front is pointing. The next condition is if Q number 3, if front is pointing max -1. You check front is equals to near, no, front is not equals to near, there is no underflow also. Now you check whether the front is equals to max -1, because if the front is pointing max -1, after deleting that so and so element, it has to move on to the next position. Since there is no next position here and after max -1, it has to go back to 0. Right? So if front is pointing max -1, you are supposed to, after deleting that element, after fetching the element and store it under the temporary variable, change front equals to -1. So here if you check Q example 2, after deleting it, front and rear would become -1, right? Suppose if this is the scenario, front is pointing max minus 1, yes, front is pointing max minus 1. After fetching this value, which means I just want to, after fetching it, I just want to ignore the space, right? I don't want this data element anymore. After fetching this, you can change the front pointer from the last to the first. After deleting it again, it has to start from the beginning, so I am shifting the front pointer over here after ignoring this value, right? Okay, the next scenario, if this is also not the scenario, go to the else part, simply set the regular scenario, check queue number 4, which is a normal scenario. If these two scenarios fails, which means the regular scenario here, so simply you can set front equals to front plus 1, that's it. Fetch the value, which means I want to ignore it, simply you can increment the front equal to front minus 1. Now front would be pointing the next position. Front was pointing 1, after incrementing front equal to front plus 1, now my front would be pointing index position 2. That's it, we have completed, we checked for all the conditions and we wrote the statements accordingly, and we can exit the pseudocode. Let me discuss again. First, you need to check for the underflow condition. If front equal to minus 1, check Q example 1, yes, the front and rear is minus 1, it has to print underflow. Suppose the front is not equals to minus 1, you have to check, which means when it is not underflow, there are some elements in the queue and there are 2 pointers front and rear. Directly you can create one temporary variable and under which you can store the value which is pointed by the front variable, because when it comes to deletion, only the value pointed by the front variable can be deleted, the data element pointed by the front variable can be deleted. So you can store where the data element pointed by the front pointer under the temporary variable. Once stored, you have to check for the scenario, accordingly you are going to shift the front pointer. If front is equals to rear, which means with both front and rear is pointing only one value, which means there are only one data element in the queue, after deleting it front and rear would become minus 1. Else you check front is pointing max minus 1, not underflow, and front is not equals to rear, which means front is somewhere else and rear is somewhere else. But if front is max minus 1 means after deleting that element, your front should be pointing 0. By mistake I wrote minus 1 here, your front should be pointing 0 when your front is pointing max minus 1. Set your front equals to 0. Otherwise, the regular scenario only, check Q example 4. The normal scenario, after once deleted, you can simply increment front equal to front plus 1. That's it, you can exit the pseudocode now. This is how we are supposed to perform deletion in a circular queue structure. And when it comes to advantages and disadvantages, again the advantages here is efficient memory utilization, because it reuses the memory spaces that are freed up by the dequeued elements. And the second advantage is constant time operations. NQ and DQ operations are performed in big O of one time complexity only. Let me write the advantages as well as the disadvantages here. The very first advantages, as I discussed before, efficient memory usage, efficient memory utilization or efficient memory usage. And the second advantage is constant time operation to perform both NQ operation and DQ operation, insertion and deletion. It is going to take only big O of one time complexity, only the constant time it is going to take. And fixed size management, it is, this circular queue structure is ideal for situations where the maximum number of elements is known in advance. These are the advantages. When it comes to disadvantages, again the fixed size is going to act as a drawback here sometimes, because the size of the queue needs to be defined in advance, right, and it cannot be changed dynamically. And the second one is complex implementation, because it is slightly more complex to implement than a simple linear queue due to the circular wrapping logic. We have to check for multiple scenarios here, right, so the implementation is complex here. When it comes to use cases, applications, it can be used for buffering buffering data. It is commonly used in buffering applications. Buffering data, it is commonly used in buffering applications like network data packets, where the data needs to be continuously added and removed in a fixed size buffer. And the second use case is memory management. It is useful in scenarios where a fixed buffer size is essential, such as in embedded systems, etc. And third use case is resource scheduling. For resource scheduling, again, the circular queue structure can be used, applied in scenarios where resources are shared among multiple processes cyclically, such as in round robin scheduling in operating systems. Thank you.